Welcome everyone. Today we are going to learn how to make a crease on a square sheet of paper that is inclined to a side of the square at 15 degrees. So as you could see, we are going to make a fold here that is inclined to this side at 15 degrees. This is just done through paper folding. We will learn the steps of folding and then we will learn how to prove the steps of folding. Let's get started. So as you could see, this is the A4 sheet of paper. So please take a A4 sheet of paper everyone and then follow the steps that I am going to instruct you. On the sheet of paper, we are going to make a cut and take out a square sheet of paper. We know that square sheet of paper is not readily available. So the way to do this is to first diagonally fold this side, the shorter one, so that it falls on top of the longer one, and then make a fold along the bottom side of the shape form, and what you are going to get is a square. This is because this angle is bisected, so this one would be equal to this one because you are overlapping on it. So now this will be the diagonal of the square and this will be the side length of the square. As you see, this is 45, 45, 90 triangle. So this is 45 degrees and this is 45 degrees. So essentially we are bisecting the 90 degrees here. Alright, so this is the A4 sheet and you are going to fold it in such a way that the shorter side falls on top of the longer one. Now you could see that there is a crease formed by that fold, which will be the diagonal of the square, and then you are going to fold the remaining piece of paper onto the bottom side of this formed triangle, and then you are going to cut this part, and you may remove this, and what you will be left with is just a square sheet of paper. Alright, having obtained the square sheet of paper, how are we going to make a crease inclined at 15 degrees to a side? Well, first I would label all four vertices of the square as A, B, C, D. Take the side BC of the square and fold it in such a way that it overlaps with the side AD of the square. So you have to fold it this way. So B should map to A and C should map to D. So they should fall on top of each other, and then you have to make a fold which will be the midline of this entire square. You see, this line or the crease formed by that fold passes through the midpoints of AB and CD. Let's call the midpoints to be E and F. We are going to use this midline extensively. So as you could see, this is the midline that will be formed as a result of your fold. So you have to fold it like this. One side overlaps on top of its opposite side. So first map each vertex and then hold it firmly and extend it a bit and then fold it with the other hand as you hold the two vertices firmly with one other hand. Now after unfolding it, you will get a nice crease in the middle that passes through the midpoint of the other two sides. Alright, here is the step number 3. You are going to take the vertex A and then make it fall on top of the midline of the square and fold the resultant about D. So how are you going to perform this? Hold the side AD with two hands. One hand should hold the vertex A and other hand should hold the vertex D. So making the vertex D still and moving the entire side AD, you have to make sure that A falls onto this line EF exactly. This is your point A now, and your fold will form a crease, and that crease is going to be inclined to the side AD at an angle of 15 degrees. Make sure that you hold the vertex A on this midline firmly, also the point D is still. That means the point D does not move even a bit. So making sure those two, you have to make a fold. After performing that, you will get the crease, and when you unfold it, you will see that it is inclined to the side AD of the square at 15 degrees. You can also check this using a protractor. Let's perform this. So as you could see, I held my fingers firmly on the vertex D and another finger on the vertex A. I'm going to move that so that it falls on the midline, but I'm keeping my fingers at D firmly and then letting it fall on the midline. So once you made sure that it is on the midline exactly, you have to hold these two firmly on the top of a table and then press the fold to form a clear crease. So once that is done, you can unfold it and check that this crease will be inclined to this side AD at an angle of 15 degrees. Let's see why this works. For the sake of clarity, I will rename this vertex as X. So we had folded along our line or crease that is inclined at 15 degrees, which is required to be proved. Now, if you perform a similar fold with C as the fixed point and making sure B falls onto the midline, you will notice that it will also exactly fall at the point X. This is due to the symmetry of the square about the midline. Whatever is happening to the left of the midline shall also happen to the right of the midline. This means the point D will also fall on the point X, making another crease here. Now, interesting thing is that XDC is an equilateral triangle. Can you try figuring this out? Well, the reason is that XD equals AD. So, which is the side length of the square. Let's call it as A. Let's call small a as the side length of the square of square ABCD. So this means XD measures A. You see, AD falls onto XD. So the length must be preserved. Not only that, due to this, these two angles are also equal. Because the angle AD and let's say this crease intersects side AB at Y, then ADY would be equal to XDY because the triangle ADY just falls onto the triangle XDY. And due to the congruence, you have XDY equal to ADY. So these two angles are equal, but for now we shall assume that we don't know the measure of that angle. Well, the similar thing would happen on the other side. You have CD and let's call this vertex, which is the intersection of that crease corresponding to the fold of B as Z, with AB as Z. Alright. Now, CX will also be equal to the side length because it is the fold done by shifting CD to CX. So they are congruent and you will get all three sides to measure the same length. So it's equilateral clearly. What is the angle measure of each angle in an equilateral triangle? Yes, it is 60 degrees. So this is 60, this is 60, and angle at every vertex of a square is 90, and the remaining angle when 60 is subtracted will be 30, and that 30 is getting bisected here. You see, dy is actually the angle bisector because the triangle, we get the triangle ADY is congruent to triangle XDY because they are falling on top of each other. In fact, that's the definition of congruence. So you have those two angles falling on each other, so they must measure the same. So we have 30 by 2, 30 by 2, which is 15 degrees. And we are done. All these angles are 15 degrees. This is such an interesting construction that we also ended up constructing an equilateral triangle. I'm going to show you the equilateral triangle we formed via this fold. So this is the first fold made by moving A onto the midline, and we are transferring B onto the midline this way. So that's done in the second fold, and this forms a nice equilateral triangle in the middle, as you could see. Now these angles are 60 degrees. So from here to here and from this vertex to this vertex, it measures 60 degrees. So the remaining angle must be 30, and that is getting bisected into two. So you get 215s in fact. So this angle from the crease to the side would be 15 degrees. Alright, I have a curious question for you. Can you construct a crease that is inclined to a side of the square at an angle of 18 degrees? A hint, 18 degrees is 90 by 5. So you have to divide an angle by 5. You may also use some isosceles triangle, some geometry, and some sort of median section. So try out and let us know your thoughts in the comments. You can also say your own construction for 15 degrees in the comments. We will have a look. Meet you all once again in another video. Thank you for watching. Bye.